Algebra 1, section 7-3, rational exponents. When we read rational in math, a lot of times what we're referring to is fractions. So if you see the word rational, a lot of times that just means that to expect to see some fractions. So here's an example. If I have b to the 1/2 power raised to the power of 2, that's the same as b squared times b, not b squared, sorry, b to the 1/2 power times b to the 1/2 power. Remember, when we multiply powers, we add the exponents. So that's b to the 1, which is just b, right? Now, keep that in mind, or remember this from what we've been doing already. But also know that b to the 1/2 power is the same as the square root of b. So the numerator goes here, the denominator goes here. So when we have the square root, this index number here would be 2. And so if this was 1/3, then this would be the cubed root of b instead of the square root of b. We'll see that later. So let's do some examples. 25 to the power of 1/2. That's the same as the square root of 25. So the 1 goes with the 25, the 2 goes here as the index number. Square root of 25 is 5. 5 times 5 is 25. Let's look at what would this look like? If I have the square root of 18, and if I wanted to rewrite this in with an exponent instead of with the radical, then I've got 18 to the 1/2 power. Let's do a few more and see if we can kind of hopefully understand what we're doing here. If I have 5 times x, and x is to the 1/2 power, that's the same as 5 times the square root of x. Now if I have 5x to the 1/2 power, notice how this 1/2 is outside of the parentheses here, then that is the square root of 5x. So hopefully you can kind of see the difference here between these two. Another one, if I have the square root of 8p, so that's similar to this one right here, then I would put 8p in parentheses and raise that to the power of 1/2. All right, now you try some of these very similar deals. Okay, rewrite a to the 1/2 power, rewrite 7w to the 1/2 power, rewrite the square root of 22. So rewrite these as a radical, and rewrite this one as with an exponent, and this one also with an exponent. All right, radicals, exponents, go. All right, let's see how you did. A to the 1/2 power is the square root of a. 7w to the 1/2 power, notice that this is in parentheses, square root of 7w. The square root of 22 can be rewritten as 22 to the 1/2 power, and 2 times the square root of x can be rewritten as 2x to the 1/2 power. So remember that 2 is outside of the radical, so this 2 is not, we're not taking the square root of this 2, it's just 2. All right, we're going to keep moving here. Nth roots. A to the n power equals b. Then the nth root of b equals a. Okay, here. So what we're saying is a to whatever power, if a to whatever power equals b, then b inside this radical with this index number is going to equal a. let's see if we can figure out what that means. So if I have 2 to the 4th power equals 16. So 2 times 2 times 2 times 2 equals 16. Then the 4th root, so the fourth root of 16 equals 2. 2 to the 4th power is 16. The 4th root of 16 is 2. So that's how that works here. So let's see if we can do some examples, see if we can figure out if we can use this. The 3rd root of 27. So what times itself 3 times is 27. Let's see if we can work this out. So 27 is 3 times 9, and 9 is 3 times 3. So look, I have 3 3's here. 1, 2, 3, and I have the 3rd root, so that means if I have 3 of them, then the cube root of 27 is 3. 3 times 3 times 3 equals 27. Let's do another one. The 5th root of 32. All right, 32 is 2 times 16, 2 times 8, and 8 is 2 times 2 times 2. Oh look, 1, 2, 3, 4, 5. I've got 5 2's, and look, I'm looking for the 5th root. So 2 times itself 5 times is 32. The 5th root of 32 is 2. Let's do one more kind of messy one, and then I'll have you guys do a U-try. So let's do one that's not so clean here. The 3rd root of 64. Okay, now for this one, I don't have a 3rd root of 64, do I? I'm not sure, do I? This is 2 times 32, and 32 is 5. Oh, maybe I do have a 3rd root. Let's see, 4 times 4 is 16, 16 times 4 is 64. Oh, so we do have that. But let's keep going here and see if we can 2 times 16, 2 times 8, and then 8 is 2 times 2 times 2. Okay, so I've got the 3rd root of 64. So I've got 1, 2, 3 2's here, and I've got 1, 2, 3 2's here. That means that comes out and that comes out. The 3rd root of 64 is 2 times 2, because I have these 2's here, the cubed root of 8 times the cubed root of 8. 2 and 2, 2 times 2, I get 4 is my answer. All right, let's go ahead and have you try a few of these. The cube root, oh, that's interesting. Okay, the 4th root of 10,000. And let's have you do another one. Let's have you do the cube root of 125. All right, go ahead and pause and do those 2 problems, and let's see how you did. Go. Okay, the 4th root of 10,000. 10,000 is 10 times 1,000, 10 times 100, 10 times 10. So 1, 2, 3, 4 tens, perfect. The 4th root of 10,000 is 10. 10 times 10 times 10 times 10, 4 tens multiplied together is 10,000. All right, the 3rd root of 125, oops, 125 is 5 times 25, 25 is 5 times 5. So I've got 3 5's here, 1, 2, 3. I'm looking for the 3rd root, so my 3rd root of 125 is 5. All right, let's keep moving. Now, I've got another little kind of example here. B to the 1 over n power raised to the power of n. So remember, when I raise these powers, I raise it to, I multiply them. So this mess right here is 1 over n times n over 1. This n right here is the same as n over 1. You multiply straight across, n over n, and that becomes just 1. So this equals b to the 1 power, which is just b. Let's see if we can figure out some examples. We can see some examples of what that looks like. I also, before we do that, well, let's do that example. And then I've got something else to show you. 125, which we just did, to the 1/3 power equals, remember the index number here is the denominator, so this goes right here, 3, and then the 1 comes over here, and the 125 goes in here. And remember, we just did this, the cube root of 125 is 5. So this is 5 times 5 times 5, cube root of 125 is 5. Let's look at another b thing here. I think I just did this out of order, didn't I? That's okay. So what we just did here, this example, here is the, here I'm showing it to you in variable terms here. So the n, remember, goes here to the index number, the b goes right here. The 1 goes right here with the b. Let's do another one. 8 to the 1/3 power equals, the 3 goes here, third root, the 1 goes over here, raised to the power of 1. The third root of 8. The third root of 8 is 2. 2 times 2 is 4, times 2 again is 8. Whew. Let's see if you guys can do a few of these, if I didn't confuse you too much. I've got a couple. I've got a few for you to do. 27 to the 1/3 power, and 256 to the 1/4 power. You might want to get your calculator out, to help with these. Do those two, and then I'm going to have an example that we're going to do together, and then another you try. All right, go. All right, let's see how you did here. So I've got the 27 in here, raised to the 1 power. The 3 goes right here, third root of 27. We already know that one. We did that one earlier today. Third root of 27 is 3. 3 times 3 times 3 is 27. So the cubed root of 27 is 3. All right, now here we have the fourth root of 256. So the 4 goes here as my index number, 256 here. Now, I don't know, what is this? I'm going to have to break this up. 2 times 128 and 2 times 64, and then I've got 2 times 32, 2 times 16, 2 times 8, and then 8 is 2 times 2 times 2. Ooh, gross. Okay, how many do I have? 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 2's here that make up 256, which is cool because I've got a 4 here. So I've got 1, 2, 3, 4 2's, and 1, 2, 3, 4 2's. So that comes out, and so I end up with 2 times 2. So the fourth root of 256 is 2 times 2, which is 4. If I wanted to check my work, I plug this into my calculator, 4 times 4 times 4 times 4, and I get 256. All right, let's look at another example here. Let's get a little bit more complicated. 64 to the 2/3 power. So this, remember, the denominator goes here for the index number, so that's 3. I'm going to have the third root of something. And the squared goes here, so I've got 64 squared. Now, one thing I haven't shown you yet, but is kind of cool, this squared can go inside here, or it can go like this, cubed root of 64 squared. It can go inside or outside, it doesn't matter. You're going to get the same answer either way, no matter how you do it. So that's pretty cool, because sometimes it's a little bit easier to take square something after you've already done what's inside here. Instead of squaring it and then taking the third root, you can take the third root first and then square it, and that makes it a little bit easier. So let's find the third root of 3. So 64 we know is 8 times 8. And 8 is 3 2's and 3 2's. So the third root, I've got 3 here and I've got 3 here. So that's 2 times 2. Let's keep going down, I guess. So I've got this 2 times 2 squared, right? So the cubed root of 64 is 2 times 2, which is 4. 4 squared is, I should put it down here to be most mathematically correct, 4 squared is 16. So 64 to the power of 2/3 is 16. The cubed root of 64 is 4, and then I square that 4 to get 16. So that's what happened. How about you try this one? 27 to the power of 2/3. All right, use this 64 to the 2/3 as an example and see what you can do here. Go. All right, let's see how you did. So I'm going to take the 3 and put that in here as my index number, so I have the third root of 27 squared. And I want to put the squared on the outside. That's going to be a little bit easier for me. So the cubed root of 27, I already know that's 3. And then I've got the squared. 3 squared is 9. All right, now we're going to kind of switch gears a little bit, and we're going to do some different, we're going to solve for x. And I'm going to get a new piece of paper here. Here's what these examples are going to look like. I've got 6 to the x power equals 216. And so now I've got to figure out what could be here. What is going to be my exponent? How many times do I multiply 6 by itself to get to 216? And this might be a little bit difficult. So what I'm going to do here is I'm going to take this 216 and I'm going to divide it by 6. And hopefully it'll divide by 6 super easy. And I think most of the ones in your in the chapter are going to be fairly easy, or they're going to work out pretty well. So 216 divided by 6 is 36. And I know that 36 goes, 6 times 6 is 36. So that means I have these 3 6's here. So 6 to the third power, 1, 2, 3, equals 216. X equals 3. How do you like that? Let's try another one. 5x equals 125. All right, same kind of idea. I'm just going to factor this, and I want to factor it with, I want to see how many 5s I can get here. So I know that 5 times 25 is 125, and so 5 times 5 is 25. I've got 1, 2, 3 5s, so x is going to be 3 again. Nice. I didn't circle this one. All right. Let's do another one here. But let's look at both of these first real quick. 6 to the x power. So 216 is 6 to the third power. That's the work that we just did here. 1, 2, 3 of 6's. So that's 6 to the third power. Let's look at this one. 5x equals 125. 125 is 5 3 times, so that's 5x equals 5 to the third power. All right, so what I just did here is going to be fairly important for what we're about to do. Because now I have something, notice how the bases are the same. Bases are the same, very important. I'm going to write that down. Bases are the same. Notice that. Okay, now we're going to move on. 12 to the 2 x plus 3 power equals 44. Oh no, what am I going to do? Okay, don't be scared. I know that 144, when I look at that, the multiplication tables, I always look at 144 and it's 12 times 12, right? So let's just write this in terms of 12 as the base, and let's see what happens. 12 to the 2x plus 3 equals 12 squared. Now look at what we did up here. When 6 to the x power equals x to the third power, I just ignored the base altogether and just said x equals 3, right? Same thing over here with this 5. 5 to the x power equals 5 to the third power. I just ignored the 5 and say x equals 3. We can do the same thing here. I'm going to ignore the base. So when the bases are the same, I ignore them. And so I'm just going to take the exponents. Since the bases are the same, I'm going to take the exponents and I say 2x plus 3 equals 2. And now I just solve for x. Subtract 3 from both sides. 2x equals negative 1. Oh, looks like I'm going to get a fraction, but that's okay. X equals negative 1/2. Let's do at least one more. We're going to do actually several more, I think. Yeah, we'll do a few more. Let's do one more kind of together, and then I'm going to have you do some u-tries. Let's do this one together. 25 to the x minus 1 equals 5. Now this one is a little bit uglier than this one here. I want to make this base the same as this base, or I want to make this base the same as this base, either one. I find it a little bit easier to go from the big one and go down to the smaller base. So 25 is 5 squared, right? So 5 squared to the power of x minus 1 equals 5. So we know that when you raise a power to a power, then you multiply the powers together. So I have 5 to the 2x minus 2 equals 5. And this is 5 to the 1, right? And so now I just say I can ignore the bases. 2x minus 2 equals 1. Add 2 to both sides. 2x equals 3. Oh, another fraction. Divide by 2, divide by 2. X equals 3 over 2, or 1.5. All right, you guys are now going to do, let's say, 3 of these. Here's a u-try that is 2 to the x equals 16. Solve for x. Another one that is 3 to the x power equals 27. Solve for x. And the last one is 4 to the 2x minus 5 equals 2. This one is very similar to this one that's right above it. All right, solve for x on all of these, and that'll be it for this lesson. Go. All right, let's see how you did here. So I want the base to be 2 over here. So I'm going to go 16, that's 2 times 8, and 8 is 2 times 2 times 2. So I've got 4 2's. So that's the same as 2x equals 2 to the 4th power. Ignore the bases, x equals 4. This one you might be able to do in your head because we've done the cubed root of 27 so many times, and we know it's 3, so 3 to the 3rd power equals 27. But if you don't remember that, that's okay. I want 3 in my base over here. 3 times 9 is 27. 9 is 3 times 3, so I've got 3 3's here. So 3 to the x power equals 3 to the 3rd power, 1, 2, 3. And so x equals 3. Now this last one is a little more tricky. I want this base to be 2. So, now, real quick, I could rewrite this as 4 to the 1/2 power if I wanted to. because 4 to the 1/2 power is the square root of 4, which is 2. 2 and 4 to the 1/2 power are the same. These are equivalent expressions. So I could write it this way, and then I would have 4 to the 1/2 power equals 4 to the 2x minus 5. I could say 1/2 equals 2x minus 5 and solve for x that way. I don't really want to, but I can. So just so you know, you could do it that way. I'm going to look at this. I'm going to take this 4 down to 2. 4 is 2 squared. So 2 squared raised to the power of 2x minus 5 equals 2. I distribute this 2 to this whole expression, and so I've got 2 to the 4x minus 10 equals 2 to the 1. My bases I can ignore now. 4x minus 10 equals 1. Add 10 to both sides. 4x equals 11, divide by 4, divide by 4. X equals 11/4. I don't know why all of these ended up being fractions, but that's just the way it is. And that is the end of 7-3. Good luck on the homework. Really work on this. Try to make sure that you totally understand it. There are definitely questions like this on the test.